Hi everyone, and welcome again to another tutorial in the TaskGen tutorial series. So today we'll be covering something very interesting. It is about wrapping this agent, which is a task solver, into a conversation interface so that you can talk to the agent. And the agent can even do some actions in return to your conversation as well. So let's take a look at tutorial 6, conversation class. So do the required setup for TaskGen. Now, what we need to do for the conversation wrapper is really easy. First, you create an agent. Let's say it's a psychology counselor. And here, what you need to do is to wrap the agent in a conversation wrapper. And this takes in the agent itself, takes in the persistent memory, which is basically what state you want to maintain throughout the conversation. So at every stage of the conversation, we update this persistent memory so that the most updated fields will be given to the agent at every turn for conversation. So like here, for counselor, we might want to ask for what are the user requests, what's the emotion, and what's the summary of the key incidents. Then how to use the conversation chatbot is really simple. This My Agent is the same as your normal agent. You can have all the tools that your agent has, like agent.run, agent.status, agent.subtask completed, and so on. But what you can do is you have a new function called chat. And this chat allows the agent to reply a certain user message with actions and give a response verbally as well, which you can print out the reply. So without further ado, let's run this. So let's say, for example, I can say, I am happy. And the bot will interpret the first message. There's a conversation history as well that will be stored in addition to the agent's status. And you can see that we can actually think about how to reply the user, update the persistent memory accordingly. All right. And then we can reply, I'm glad to hear you're feeling happy. So all the things above here, actually, you cannot show to the user at all. All you need to do is just show this reply. So it's very easy to interface this with Gradio and so on. Check out the sample notebook on equation game for more information. So here you can see that like I can say like I can do TaskGen full time now. So we can see this, and this should update the persistent memory as well. You can see that the summary of key incidents has been updated. All right, and users shared that they can pursue TaskGen full time. So all this state will be very useful to continue throughout the conversation so that the agent has the best knowledge needed to reply the user. So we can just exit this. We can see that we have new variables called conversation in the shared variables, which you can see what other user and the agent's reply. So, if you want to do this in the multi-agent setup, all you need to do is to just, keep giving like the earlier chats to different agents. Okay, and then, you could get the different agents to reply and add into the chat and so on. Okay, this will be coming in a later feature called multi-agent chat, which is not here yet. But just from this architecture alone, you can see that by just wrapping it over one agent or many agents, you can do wonders based on this. All right, and you can see that you can even get the stuff in persistent memory. Not just summary of key incidents, you can just get everything in persistent memory as well. So it's very easy to access. All these are just augmentations to your base agent. So something really cool here, this is the Jarvis system. So Jarvis is like, Iron Man. Here we augment it with like the status of the machines, give it travel abilities, give it ability to check the enemies ahead, ability to fire missiles, and ability to top up missiles. So you can see that this Jarvis agent, this is the prompt, and it has global context with the information that is needed, like what are the enemies and so on. So let's run this, and maybe I can ask it to like, hey, travel to Mars. And what it can do now is it can take the action travel to Mars. All right, take it, and then you can see we call the function travel to Mars. Here in the conversation class, I only allow for one action, but you can do your own conversation wrapper and make it more actions if you need to. You can see that this action is done. It's basically a summary of what has been done, and this will be fed to the agent's context when they reply. So when the agent replies, I've successfully traveled to Mars. You can say now search and destroy combatants. And you can see what happens now. What happens now is that it would check the enemy info. There's one paramilitary unit ahead, and they'll ask, do I have your approval to proceed? Yes, fire. Yeah, you can give approval to fire the missile and so on. And next up, what you should do is you should call the fire missiles. And just to play safe, we also have a safeguard in the fire missiles function to just make sure that you must approve it in the function before it's fired. All right. Stuff like this, if you are doing like weapons, it's a bit dangerous to let the LM decide. So it's best to still have human intervention. And this is just how Iron Man suit might work. So these are the shared variables you can see. Everything that the agent can do, this conversation wrapper can do as well. It's just that it adds more things like persistent memory and the conversation stuff. Right? You can see how we have done this. It's just basically just wrap the main agent in a conversation wrapper, just like this. As easy as that. All right, other things that you can do with it is like shop assistant. You can give it some stuff like to search items by category, to buy items, and you give it the global context, which is like what has been searched and what's the conversation and so on. So you can say like, what can I access you today? I am quite thirsty. And let's see what the assistant replies. And like, oh, it was searched for beverages. So this is a very smart search based on the conversation. And we can say, oh, my dear friend, we have gotten this juice for 3, coconut for 10, and apple for 1. Give me the coconut, maybe. So you can just say something like this. And okay, right now you can see that there's some error passing, but no problem. JSON tries to correct this. And in the end, we get back this. And you're about to purchase coconut. You can say yes. So, all right, so that's great. My friend coconut has been procured successfully. Very good. So we can just exit. So this shows you how to use the conversation wrapper to do like shop assistant and so on. Just try to put rules whenever possible so that, like when you want to buy items, make sure that, you have enough money and so on. That can be hard-coded rules and so on. Because LMs may not be great with numbers. And like stuff like this, the item ID, if you just change the name to like maybe item number, maybe it will work better because sometimes if the key fails to generate, just changing the name will make it more reliable. So this is perks of your own LM. All right, so we can even do something like a math board, this is actually not that great in terms of like rule-based things because LMs may not do math well, but you can also incorporate your own rules here after the conversation. You can check the like answer from the user, and then based on the answer from the user, you can just do a rule-based thing to see whether is it the correct answer or not. So we can incorporate some form of rule-based things while doing the conversation and use these rule-based things to guide the conversation by like putting it as an oracle and so on. So it's very flexible. You can just interface this chat as part of your pipeline. You can see over here. What we want to do is like, hey, what's 2 plus 3? So what's 2 plus 3? Maybe I answer something wrongly. I answer it is 2, of course. And let's see what happens. So you can see it's wrong. That's not quite right. If you have 2 fingers and 3 in the other, how many fingers do you have? 5, of course. Let's try to answer without the number and see whether it understands this. And great job, you're right. 2 plus 3 is indeed 5. So you see, even if you do in terms of words, it can still detect because backend is using strict JSON to check whether there's a number and extract out the number. So it works for, sometimes you spell it wrongly or you do it numbers. It's very flexible. So this is an example of a rule-based system to do a quiz bot. So the caveat is agents are generally not that great with certain logical stuff. So it's best to use rule-based things whenever possible. So this is an example of how to interface rules with the chatbot itself. So feel free to play around with it and see what works for you. Next, we have an escape room. Like we need to escape from the room, take certain things like, in this case, pick up the key and go to the door. So let's try this. Okay, so we have the escape room solver. You must output one of the available actions and we wrap it in a conversation. So what this means is that every time when you interact with the game environment, we update the inventory, list of past actions, summary of past actions, list of room explored, and so on. Right? And in this case, we can refer to the person as the game. So this is a cool way to do problem solving by putting the environment as a second player in the conversation, second person, and then use the conversation to solve it. So we can see the agent now is replying, hey, pick up the key, and then next unlock door, and then exit. Done. Okay, so this was quite simple. Let's try to see whether it can solve like 2 rooms instead of just 1 room. And we can play the escape room and see in room 1, what it does is pick up the key. So here we have all the actions. If you want to hide the actions, it might be a bit harder. You might need to store the list of actions in another memory buffer. But all this can be done with additional augmentations. Not a big problem. Here we can see that, hey, enter next room, and then in room 2, pick up treasure, all right, unlock door, enter next room, and done. We have solved the escape room. So for those who think that this is actually quite simple, it's actually not. So if you just ask the LM to do this without any memory at all, there's a high chance of failure. Okay, so this persistent memory is very good to keep track of states. In fact, if you have a knowledge graph or state graph, you might want to give the agent at every conversation by augmenting it in the chat, or you can augment it in the agent's global variables, okay, which is over here, like global context. You could do that, and this will make it more reliable and more robust. So I leave it to you as to how to make it work for your use case, but you can see in this conversation class, simply wrapping your agent in a conversation wrapper, and you are free to modify this conversation wrapper as you please. Just go over to the contributions page, contributions folder, you go to agent wrapper. You can modify it, anything of an agent. You want to change the built-in functions of your agent, no problem. You just need to create a wrapper over your agent. And this is an example wrapper to show you. So you can just, wrap your agent and then init it, assign the functions. And what you need to do is just declare your own additional functions here, or override the existing functions for your agent. And you can do various functionalities. And a lot of functionalities that I'm thinking of and still building is like planning, reflection, verifier, conversation, multi-agent conversation, and so on. So really cool stuff. I hope you like it and contribute your own favorite wrappers to it as well. Make the framework more useful for everyone. And with that, thanks for watching, and I hope to see you all around. Okay, bye, everyone.